Welcoming everyone to session one of the day. In this session, we are going to discuss about the play concepts and industry best practices. I would like to take the opportunity to introduce the distinguished speakers of the session. Dr. Rabi Bastia, President, ENP Oilmax Energy. We welcome you, sir. Dr. Bastia is a reputed personality in the energy sector whose endeavor has been significant to put India into international oil and gas map. After heading the exploration group of Reliance for more than 16 years, he has currently taken up some very distinguished and challenging assignments both in India and abroad. Besides his current position as President Oilmax, he holds the chairmanship of Masira Oil Limited Oman, which has made the breakthrough discovery in Oman Eastern Offshore for the first time. He also holds the directorship in Asian Oilfield Services India and other international board positions such as TIW Private Equity. We welcome you, sir. I would also like to introduce Dr. Nicolas Hawie, industry expert. With more than 10 years in the internationally renowned French Institute of Petroleum and its subsidiary, Basib Franlab, Dr. Hawie held senior project management and team leader positions. Dr. Hawie currently acts as a senior independent petroleum systems analyst to prominent international and national oil companies, as well as governmental agencies, energy ministries, and academic institutions. He also acts as a scientific reviewer to major international oil and gas journals such as the AAPG Bulletin, Basin Research Marine, and Petroleum Geology. We welcome you, sir. I would also like to introduce Dr. Bjorn Wygrala, industry expert. He is also the session moderator as well as the speaker for the session. Dr. Bjorn Wygrala has a PhD in petroleum geology from Cologne University in Germany that was supported by ENI, AGIP, and the KFA Research Institute. Bjorn recently retired from Schlumberger after 40 years in the industry, starting as a sedimentologist in uranium exploration in his home country, Australia, followed by global coverage of the oil and gas industry in services and business development with ENP companies in more than 70 countries. We welcome you, sir. Sir, may I now request you to commence the session, please?
Right. Hope the audio is okay. Let me know if there are any issues. So here's Bjorn Wygrala speaking.
Yeah, we can hear.
Okay, very good. Thank you. So I'm speaking from Cologne in Germany. Springtime here, very early in the morning, but quite nice. And it's a pleasure. I was really happy to receive this invitation because, as many of you know, I've spent a lot of time working in India, especially on the 2017 resource project, the National Resource Project of India. And so I'd like to kick the session off and ask Dr. Rabi Bastia to give his talk. And I have a memory, this is quite some time ago, visiting Reliance for the first time in the new center they had outside of Mumbai, and it was like driving into the area, and I thought all of a sudden, oh, I'm in Houston. It was really sunny, a fantastic venture, very successful.
Yes, I do remember, my friend.
So it's a pleasure to be here again, even if it's remote. And so, without further ado, I'll hand over to you, Dr. Bastia, to give your talk. Thank you very much.
Good morning to all of you. The tone is already set by the DGH and ADG. I will try to give in the next 30 minutes my sheer optimism for this country and portray the dynamics and the current trends in the play-based exploration by unraveling some of the mysteries which have not been solved so far. I promise at the end of 30 minutes, I will add some burning points to your candle for the dreams, for the decade of discoveries to create an energy revolution in this country. With this, before I start, I will start with the picture which is there on the first slide of my screen. It's up to you whether you go to fetch the fruit first or try to understand the tree first. If you want to get a bunch of fruit, probably that is the prospect mapping or prospect hunting. If you want to have a branch of fruits, a branch with tremendous quality fruits for you, you have to go for a play-based exploration. My outline of the presentation will be, I will try to define the play-based exploration in the very, very broad terms, make the workflow very clear to you so that we all tend to follow a steps workflow for the play identification, the play element mapping, the innovation and creativity, which has been the integral part of the play-based exploration, then few examples of the Indian basins, and then construct a roadmap for future. The definition could be very simply termed as part of exploration where the fundamental logic of geological plays is explicitly understood and fully levered to underpin a range of related exploration activities. The important thing over here is the range of related exploration activities in the entire cycle, starting from the new venture to the venture execution. We are not here just to go in peace for a fundamental logic to unravel the geologic play. You are here to underpin the range of related exploration activities which are important in this deal. So we have the definition, stratigraphic as well as aerial. Often we confuse with the stratigraphic definition from the aerial one. The stratigraphic play definition is commonly construed by the play boundaries, which are the sequence stratigraphic events, that is the regional unconformity. Please remember, you should not combine more than one mega sequence into one play. Never. When you try to define the play, sometimes based on the aerial definition, this is the maximum horizontal extent within which the hydrocarbon pools may belong to. So that could follow the pattern of a contour, which is probably understood to you. So in summary, if you want to understand the definition of the play-based exploration has given us a major portfolio shift in our approach. Harvesting the old plays is the fundamental one normally people tend to do. But when you go to the new plays in the old basin and the new plays in the new basins, the play-based exploration comes in. So the fundamental portfolio shift in the play-based exploration is taking you from harvesting the old plays again and again with the old ideas to the newer plays in the older basins and the newer plays in the new basins. This is the standard definition of a petroleum system play and prospect, but I would like to point out few very important and significant aspects here. The petroleum system is once active source rock in the geological elements has to be understood. The fundamental to all the petroleum accumulation starts with a source rock. When we start from the prospect hunting, probably from a seismic line and creating the maps from the seismic alone without the regional and the tectonic framework reconstruction will not give you the idea of a source rock reconstruction. So when you connect the trap, seal, and the reservoir, but the linkage between all of them to the source could be missing. So it is very important to really understand the occurrence, the nature, and the geometry of the extent of the source rock, which are critical for our play analysis. Next one. This is the pyramid, which is the famous pyramid. So when we start with the basin focus, we start understanding the plate tectonics, the tectonostratigraphic framework, the mega sequences and the basin field, and construct the regional map. So from the regional scale, we come to the semi-regional, where we try to identify the prospects, and here we construct the geologic model by the detailed geophysical evaluation, and then get into the volumetrics, risk, and uncertainty analysis before maturing a prospect. So the pyramid is the prospect comes at the top of the pyramid. We cannot start our game with the prospect, which never lead you to the fruits which could be hanging elsewhere in the same play types. We call it 8 steps to nirvana. So the steps in building a play starts from the basin characterization, tectonostratigraphic framework to sequence stratigraphic analysis, and then comes to understanding the basin structure and the fill pattern through time. That is the basin evolution. This is very critical. You don't have to understand the basin, which you see today only, but you have to understand the basin, how it has evolved through time. Then reconstruct a source, reservoir, and seal distribution, and then assess the petroleum system through a chart. The last step before the prospect identification will be the trap distribution, where the geometric relationship and the palimpsestic reconstruction of the trap timings and the size maps are prepared. So these are the 8 steps which we tell that the steps to nirvana, building the place. The play identification, what drives the new material play identification in the proven basins? Whether it's new technology, new play model, assess, new commerciality boundaries, or serendipity. So let me just deal with all these 5 with some global statistics. The significant new plays identified in the old basins, when we see the numbers and the distribution, probably the newer play model with a newer concept can give you to the maximum results. You can always argue serendipity has also played a significant role in our prospect hunting or the play analysis. But please believe me, the serendipity, even if you discover the size of the discovery and the optimal nature of the total number of discoveries could be there in the play, will be limited for you. So the new play model is the most critical one, though the other aspects of technology, the access to the data, and the commercial boundaries are quite critical in our analysis. I will give you some quick tricks for which I have tried to learn in my long 35 to 40 years of career in this business. How do you quickly look to the signature before you get into this analysis? both in terms of the seismics and the logs. How do you define the sequence boundaries? Here is some sort of a fundamental nature of the wear-line logs, where the fining upward sequences and the distribution of the fining upward sequences are probably determined by the flooding surface. And those flooding surfaces would be the boundary for the sequence. And they could be termed as your sequence boundaries and the play boundaries. So you need to search for the plays in each one of them separately. When you correlate them to the traces in the seismic, you could find a pattern. And those patterns will be important in identifying the mega sequence boundary in the seismic. So if you don't have the well-line logs control, probably you have to get the flooding surface from your regional understanding. And the spatial distribution of the play normally comes from your understanding of a horizontal surface, which you draw from a normal contouring of understanding the regional geology and the tectonics. The seismic, the beauty of the seismic, it can give you some ideas of a basin. This is a picture of a basin field. You could see a basin field and feel very happy that at the side of the basin field, you could have probably a discovery. But please remember, the basin field, they don't come in isolation. You can see the first sequence, there are A, B, C, there are three basin fields associated. They are conjugate basin fields. So if you get one, please try to find out the others. How do you do that? You have to start from the bottom to get into the play analysis. Similarly, in the sequence 2, you could see there are 7 basin field identified. This is a compressed seismic section. I wanted to show you, when you see some seismic features, it doesn't end there. So if you go for the exploration in the holistic manner as a play-based, you will find the similar features, as because nature doesn't permit things to happen in isolation. Most of the times, nature follow a pattern, and please follow this pattern, because geoscience is nothing but the art to follow a pattern which is sometimes recognizable on and visible on the demonstrable seismic sections, but many a times it has to come through your mind. The play element mapping. A play map is a visual description, the petroleum system, which synthesizes the areal extent of the charge, source, reservoir, and seal. That is the reconstruction of the play map. Then how do we do that? Normally, this is the overlay of all these 4 important aspects, and the common point of all the 4 becomes the play outline. So this is normally the practice for the play element overlay. But when we prepare a play map, it should insert some other aspects also. Next one. The play map workflow should naturally consist of a play map, but it should also have the information on the dry wells which have been tested in this area, the drilled hole analysis, the play across sections, the insert maps with the database, insert maps with relevant geological play elements, the petroleum system chart. I am unable to show the pointer here. If you see, there are 2 wells which have been drilled here. The first well got drilled and people got very excited, and with some sort of prospect to prospect jump, the second well was drilled, but it has missed the target, as because the channel lobe just bypassed the second well and it is outside the play type. So when you reconstruct the workflow, you cannot remove any sort of element which could be critical for this play analysis. So a shortcut could enhance your risk of finding hydrocarbon in the right earnest. How do we improve our evaluation? Basins must be looked at both their present tectonic setting and their paleo settings. Remember, a basin can experience different tectonic events over its history. That's the reason we try to reconstruct the plate tectonic boundaries before getting into the regional understanding of a particular basin. Next. Innovation and creativity are the major aspects of a play-based exploration. Starting from the broad vision, which is regional, you come to narrow your search with a semi-regional understanding, then focused by a detailed approach, and then derive the final product, which will be the play. Friends, problems cannot be solved by thinking within the framework in which they have been thought or created. Do we have the right stimulating environments for the new play innovation? The stimuli are new ideas, new data, and the new technology. The collaborative creativity and the teams with individual excellence are quite critical in this game. 6 key behaviors which are important in this game will be the freshness, getting enough of the right stimulus to help think differently. The greenhousing, keeping young ideas alive and healthy, realness, momentum, signaling, and courage. The courage to think differently and sometimes be wrong. But that is the way the play-based exploration has to go on. Now I come to the Indian basins before we construct a roadmap for our future in the next 10 minutes. Indian basins could be broadly subdivided to 3 categories: the collision, shag, and rift. When we divide them into these 3, we can also make some sectoral analysis based on these fundamental understanding of the tectonics. Next one. I will get you some mantras for understanding the model seismic response quickly from a seismic signatures. When you get a very strong peak and a strong trough at the mega sequence boundaries, this could represent a good seal and a good reservoir if your petroleum system and the play analysis work is about to be complete. If you get a moderate peak and a strong trough, probably a poor seal and a good reservoir. A strong peak and a moderate trough, good seal and a poor reservoir. Poor seal and poor reservoir by a moderate peak and moderate trough. So these are some of these basic framework which we have drawn in our mind. I thought I will share that with you. When you get into the second stage of play analysis, for a quick model seismic response, this will be a great help to quickly map the play. Next one. I will now give you the second trick. We normally jump to the stratigraphic features which are very prominently seen on few of the seismic lines. For example, if I get a unlapping sequence, don't stop there, because those unlapping sequences belong to the top surface of a sequence, mega sequence, where you have off flap and top flap also. So stopping at the unlap alone will not complete your exploration cycle. Similarly, when we are seeing a downlap, the bottom surface, this denotes the bottom of the mega sequence. But when you see that you have to look to the truncation boundaries at the top to find your top lap, off lap, and on lap. In this process, not only you will find one possible prospect, but probably could locate few more prospects which could be associated in all these stratigraphic features. So the points which I tried to make here, the quick look interpretation by the trace of the seismic and seeing some signatures will give you the stimulus to see further, not to stop at this stage, getting happy to get a prospect there, which could be a successful one, but what next? So we lose our track at that point. So please go beyond by looking to some of these features, which could be the associated features surrounding them. Some examples from the Indian basins. Most of our Indian basins, when you go to the coastal basins, especially, you will be finding the self-edge break. That is quite significant. So that demarcates the staging area. So there, you will have the mega sequence boundary, which is very critical to us. The 4 mega sequence boundaries, which are shown here in this, are characteristically present in the entire east coast, where we could see a self-slope break. So this is a very fundamental to all our Indian basins, especially the coastal basins. Next one. When you go to the carbonates, not only we are looking for a buildups at the carbonates, which could be there at the tip of a wedge, but please see, along with the carbonate buildups possibility, the possibility of the Paleogene carbonates and the clastics, which could be there down deep in the mega sequences. So that will be the series of prospects which could be associated within the limits of this mega sequence boundaries. Next. You see a very prominent structural trap, but this structural trap alone is not the end of the story here. You could see in the depression left to the structural high could also have the stratigraphic features, which are equally important as the stratigraphic traps. So gone are those days, you will be looking for some easy prospects in the structural highs, which are obvious to be mapped, but there could be some prospect, associated prospect in the stratigraphic features, in the basinal loads, which are equally important, which could be large distance and the aerially could be very, very significant. This is from the 85° east reach, how when we are looking for the basin exploration, I would consider this probably is the end of our deep water basins and our exploration search could probably go up to this in the right earnest. And when we are connecting the coast up to the 85° east reach, you will be drawing a lot of mega sequences in the entire east coast, starting from the Bengal to Krishna Godavari to the Kaveri. This is one of the global analogy. I am always tempted to show it in the classes when I go for play-based exploration techniques. And when you see at the top, these are the salt tectonics. Normally, those structural features at the top, the salt-related activities.
Dr. Bastia, sorry to interrupt, but we're running out of time a little bit. Just a reminder.
Might be 2 minutes.
In a few minutes.
Okay. So those features, I would like to just advise that when you see such features, there could be some possibility of below salt exploration, which had emerged as very big potential all over the world. Similarly, when we see some dumps of basalt or dumps of some dikes, we could have the possibility of some exploration possibility down below. So these are the basin below basin exploration, which are some possibility in Indian context. Next. My concluding remarks. We construct a roadmap for our country. Divide all our Indian basins into 4 to 5 sectors, depending on our regional tectonic framework understanding. Engage dedicated professionals to each group to create the play maps for all the sectors. Then integrate them and build the play atlas. That play atlas will serve as the guide for exploring the Indian basins which are not been explored so far. Ascertain the chance of success, little more to the discovered basins area and relatively less to the frontier area where the understanding is relatively poor. But when you develop a mixed exploration strategy as a regulator or as a decision maker, the exploration strategy has to be mixed with both with the low-hanging discovered basins, close to the discovered basins, prospects or the plays, with the relatively less known, but could be very big if the discovery is found in the frontier basins. So that should be the approach to my mind. Belief is very important in this game. Support the focus area. Do not follow the history alone. Creative environment is critical in our business of finding the play or the newer play. And with this, I am quite optimistic that in Indian basins, we still have a lot of potential left. And with a proper play-based exploration tricks, we will unravel some of these mysteries. Few of the recent findings in the Vindhyan and the Bengal has shown that all are not over in India. And with great optimism, I now open the session and hand over it to the organizers. Thank you very much and have a safe stay with your family, friends, and home.
Okay, thank you very much. And you have the history to prove that being creative is a really critical aspect in exploration, trying to open new plays. So thanks very much for the talk. So without further ado, I'll hand over to Dr. Nicolas Hawie, and we will hopefully have some time at the end of the session for questions. So let's start straight away. Dr. Hawie, I hope technically everything works, so I'll hand over to you.
Everything is working well. Thank you very much. Let me just share my screen with you guys. So hopefully you see the screen right now.
Not yet. Here it's yes. I think it's yeah. Okay, good.
Okay, I have your green light.
Looks good.
Thank you very much. So I'm happy to be here today with you guys. Thank you very much for the invite. All my heartfelt feelings with the Indian people, and I hope everything will be well. Stay safe, all. So first of all, we'll be discussing about de-risking of petroleum system elements in complex sedimentary systems. In this presentation, I'll be using a more holistic approach and be discussing in more details the use of innovative numerical forward stratigraphic modeling approaches to try to de-risk as much as possible petroleum system elements. So in the previous presentation, the focus was a lot on the GNG data, which now will be shifting a bit more towards the new approaches or innovative approaches that we use in numerical modeling techniques. So just to give a brief overview, and I'm sure everyone knows about this, but the petroleum system elements usually includes all the geologic elements and different processes that are usually essential to generate hydrocarbon accumulation. Of course, there's many elements that needs to be assessed: source rocks, reservoir rocks, seals, trap, and migration mechanism. All of these elements and processes are actually important and needs to be correctly placed in time and space, so that we are able to assess how is organic matter being produced, how is it buried, and then migrated into an accumulation. So if we want to focus a lot on the assessment of petroleum system elements, of course, we need to reconstruct the evolution of the plates and the evolution of the depositional environment through time and through space. And for that, of course, I'll focus a lot on sequence stratigraphy, and I'm sure all of you are very aware of the applications that we use. These applications have been used for decades in academia and government, but also in industry. And the thing I want to focus a lot on is the importance of integration in this work. We need to integrate disciplines, we need to integrate data, but also we need to understand the main control on the evolution of the sequence stratigraphic frameworks that we have. When I think about the integration of disciplines, I mean sedimentology, stratigraphy, geophysics, understanding geomorphology, geochemistry, structural geology, and basin analysis. And I'm sure that throughout this presentation we'll be discussing, and the next presentations will be discussing a lot about the different disciplines that usually are important to de-risking petroleum system elements. But also something which is very important and sometimes people miss out is the integration of data and the scaling issue. Seismic data, outcrop data, core data, well log, for example, biostratigraphic data, and geochemical or geomechanical data also that can be used. Scaling issue is a very important point, and I'll focus on it in the next couple of slides. And what I want to highlight is the fact that in order for us to build up an integrated approach or a holistic approach, we need to understand the challenges related to disciplines, to data, but also to scaling. Assessing sequence stratigraphy and assessing the depositional environment through time needs a thorough understanding of the different controls that are usually playing a role on the evolution of accommodation space or on the sequence stratigraphic framework that we are looking at. Of course, we'll be discussing about sea level changes, we'll be looking at subsidence, we'll be looking at climate, sediment supply, basin physiography, looking at environmental energy, biota, and all of this again into the dependency on the scaling approach. Are you looking at the first order, second order, third order, or even fifth, sixth order stratigraphy? So what we have built along the past decades and lately the past years is a fully integrated approach. And I think what needs to be really pointed out here is that seismic scaling and the integration of seismic scaling in the perspective of this holistic approach of de-risking petroleum system element is a very important perspective to keep in mind. Of course, seismic sections can be looking at geodynamic or tectonic evolution on a larger scale. We can be looking at seismic stratigraphy and geomorphology, as my previous presenter has showed you, but also we'll be looking at modeling and delimiting all the depositional environment features and facies that are expected in 3D through seismic inversion and characterization. This is at a large scale, but whenever we're looking at a 1D or 2D scale, we're looking a lot at outcrop scaling. We're looking at sedimentology and stratigraphy through core data. We're evaluating through petrophysical logs, but we're also looking in details at geochemistry. And all of these different, if you want, disciplines needs to be integrated, even though they present different scales, they need to be integrated to develop a conceptual geological model. So before getting into the numerical modeling approaches that we will be discussing, there's an important weight that needs to be put on the conceptual geological model. Of course, different geologists will have different models, will have different approaches, sometimes different correlations. And it's up to us, through forward stratigraphic modeling and later on basin modeling, to try to de-risk the different petroleum system elements. Today's presentation, I will be focusing a lot on the 3D stratigraphic forward modeling, and these are new modeling approaches that allow us to understand and de-risk the depositional environment evolution and the sequence stratigraphic framework of the petroleum systems and of the basins that we're really looking at. Following the understanding of the different facies in carbonate, silicic classics, but also mixed settings, we will be able to inject facies into basin models that will highlight and model the evolution of source rocks and the hydrocarbon migration from the source itself into the reservoirs and the traps at some point. Following that, we will be able to de-risk using resource assessment and lead and prospect evaluation the different prospects or the different leads that we are looking at in a much integrated G&G and numerical modeling approach. So for those of you who are a bit familiar with sedimentology and stratigraphy, of course, there's a very important aspect that we need to always define is the understanding of the source-to-sink approach, usually in mixed sedimentary systems. Of course, all of you who have been working a lot on siliciclastic systems understand very well that most of the sediments are usually provided from the hinterland, from the erosion of the hinterland. And through weathering, through erosion, but also through transport, we will be driving sediments from the catchment area into the sink, which is our basin at some point. In order for us to really model and really understand how these sediments are being transported along space and also along time, we need to really assess the processes that play a major role on the transport and deposition and then burial of these sedimentary systems. If I want to simplify in a siliciclastic system, of course, you have the erosion of the mountains, you have the development of meandering or braided river systems, and then we generate anastomosing systems around the delta plain, and at some places you have important canyon systems and development of deep water fans. But along this source-to-sink profile, at some point you will be also developing some carbonate systems, and these carbonate systems will be acting differently than siliciclastic systems. So if we get to a bit more complexity into the ecological interaction and the assessment of your sedimentary basins, we need to approach the understanding of a depositional environment through different parameters. If we focus a bit on carbonate systems, of course, we need to look at bathymetry, we need to look at the wave characteristics, at carbonate production laws, we need to look at temperature, lighting, ecology, the carbonate factories on which you're working at, because you know very well that carbonate factories are changing through time, depending on the paleogeography and environmental aspect that is impacting our shelf or our ramp system. And how do we transport these carbonates? Are we transporting these carbonates through wave, through gravity, but also through a potential river close by? Something also which is important to keep in mind is the understanding of sabkha or hypersaline environment, because all of these depositional environments will play a role on the play and of course on the petroleum system elements, going from precipitation to evaporation, understanding the different salinity index, looking at the ecological system of salt or evaporites, wave energy, siliciclastic influx, and also production and dissolution rates, which are important parameters that will allow you to develop but also to preserve your hypersaline environment or your depositional environment related to salt and evaporite. And finally, to conclude with is, of course, the siliciclastic continental and marine environment, where source location is important to assess, water discharge is important to assess, how do we transport our sediments, and of course, how do we erode, and when do we activate our source. It would have been too easy to model a siliciclastic system or a carbonate marine environment if some of the processes were simplistic. But unfortunately, a lot of work has shown the complexity of the interaction of the different processes. Of course, here I've put a lot of publications that you can check, and all of the work that I'm presenting here is actually published in international peer-reviewed journals, so don't hesitate in case you have any questions or requests for publications. So, whenever we're looking at assessing plays or petroleum system elements, there's a lot of uncertainties that we need to account for. And these uncertainties will actually affect the risk or even the sensitivity of our geological model that we are proposing. We have data uncertainties, which are related to the volume of data, to the spatial extent of your data, to the type of your data, but also to the quality and consistency of your data. But we should not forget also that there is an interpretation uncertainty. So a lot of questions will be generated at what do we have in between wells? How can we extrapolate in regions where we don't have any data set? And this is important in frontier areas or in areas where we don't have a lot of data set already provided. And how is the complexity of integrating all of this multi-scale but also multidisciplinary data? And where do we integrate it, and which type of softwares do we integrate it, and how can we use, for example, AI to integrate and to understand all of this data? And at the end of the day, I will also point out to the non-uniqueness of interpretation. And this is why modeling or numerical modeling and sensitivity analysis will play a major role in the assessment and to de-risking of your play and petroleum system elements. So if we go to the numerical modeling approaches, you have, of course, the whole data set, the G&G data set that you already know from geology to geophysics to petrophysics. Now, historically, you have what we call data-driven modeling techniques, which have been used along the past decades, which can be deterministic, but also stochastic modeling techniques that will allow you to model a reservoir or to model a petroleum a system element or even a play at some point and generate, at the end of the day, a flow model. But we have also new methodologies which are more process-based methodologies. So we use equations, I will not bore you with that, but we use equations that are mainly related to the process of the sedimentary system and not only to geostatistics. And once we generate these process-based modeling approaches, we will be at some point generating a high-resolution static model or a basin-scale stratigraphic model, which will help you de-risk your plays and your petroleum system elements. So what is the difference between historical stochastic data-driven methodology versus forward stratigraphic innovative process-based methodology? If we look at the historical methodologies or the methodologies that are usually used in the industry for the past decades, we see that all of the facies or all of the petroleum system elements are actually populated based on data. If you have well data, if you have seismic data, you will be populating in 3D or in your cube, your facies or your characteristics or properties of or petrophysical properties in 3D based on data constraints. They can be well data, they can be seismic data. But sometimes geostatistical approaches are not always able to approach complexity of the positional environments. So we have a good correlation in terms of your data, but sometimes you have a poor correlation with your geology. So what we have been developing along the past decades is an integration of forward stratigraphic modeling techniques or process-based modeling techniques, which are usually highly predictive in terms of geology, and stochastic methodologies, and generate what I call hybrid models. So these are models that take into account data-driven, but also process modeling techniques to de-risk as much as possible the petroleum system elements and your play. And also you need to remember a lot the scaling again. Remember, whenever you're correlating a well to a cell of a model, you need to take into account the scaling, or whenever you're looking or you're comparing a model to a seismic data, you need to look at vertical and lateral scale. So what are process-based forward stratigraphic models and what do we usually use them? Process-based models are usually deterministic tools that produce the interaction of different mechanisms that will drive your sedimentation or your sequence stratigraphic evolution. So they can be modeling the subsidence, we will be modeling the bathymetry evolution, the sediment transport, the in situ production, erosion, the static sea level changes to generate geologically sound numerical models. I will not bore you with the equation, but I will tell you that these types of modeling techniques are actually applicable using diffusion transport equations. So these equations allow you to understand how do we transport sediments from your source to your sink through processes of water discharge, through processes of gravity, but also at some point through processes of wave. And also carbonate production laws and evaporite production laws that will help you to develop carbonate or evaporite into your system. So to simplify it as much as possible, and I know not all of you are expert in this field, but to simplify it as much as possible, the workflows that we usually use take into account the integration of all the G&G data, from well data to seismic data to petrophysical data, and also to circulation model or water circulation model and global paleo topographic models into understanding the initial paleobathymetry of your system, looking at the subsidence, using your static sea level curves, which are acceptable in your region or in your local basin, looking at sediment supply and production. Are you looking at carbonates? Are you looking at mixed system, at evaporite systems? All of this is very important. And then at transport processes, so that we are at some point able to define and model facies. The main aim for us when we use these types of forward modeling techniques or process-based techniques is to generate various scenarios. And these various scenarios are actually representative of the depositional patterns that you will see in your system. This is an example of 3 different scenarios based on the usage of different eustatic sea level curves. We have a high resolution sea level curves at first, and here we're producing, for example, a progradation of a carbonate platform system, where you will see in bright yellow high wave energy systems and in blue mud deposits or low energy systems. You can clearly see the interaction and the impact of wave energy on the different profiles and the different clinoform systems. So you will see that you have a clinoform which is rich in grains, and then a transgression which will lead to the development of a relatively finer transgressive systems, and then again prograining geometries. And comparing this to low resolution or low frequency eustatic sea level curves, which will of course generate less frequency into your system and less resolution to your model. At the end of the day, and this was one of the main challenges that we see in the industry, is how can we use forward modeling to de-risk petroleum system elements? And one of the major answers to that is to integrate this workflow in a sensitivity analysis assessment by using multiple automated realization and sensitivity analysis realization to generate not only one single model, but a combination of various models and generating what we call facies probability maps or petroleum system elements probability cubes. This modeling techniques, this is an example showing you a model that we generated in the Gulf of Mexico with a deforming system. You can see two canyons generating sand lobes into mini basins, which are affected by salt. Another example of siliciclastic work was the work that we have generated for Nova Scotia, Canada. This is just to show you the importance of using forward stratigraphic modeling and process-based techniques to try to assess the diversion of your channel systems, the lobe development at the front of your channels, looking at the influence of salt or mud deformation on the diversion of the channel and thus on the development of, for example, reservoir characteristics, but also of sealing facies and seismic stratigraphic or sequence stratigraphic trapping mechanisms. Remember very well that what you will see here on these maps, you can see that everything in yellow and brown here represents deltaic or fluvio-deltaic environments, and everything that you will see in brown with some small streaks of sand represent actually turbidite or basin floor fans. Now moving again to comparing some of the models to the seismic data, this is an important aspect and an important process that you usually take into account whenever you're modeling. You need to calibrate your models to well data, but also you need to calibrate your models to the seismic data in 2D, but also in 3D. This is another example that we have generated and worked on with the University of Texas, Austin, and this is showing you very high resolution models for basin floor fans and compensation stacks. And you can clearly see channel levee system developing into compensation stacks and frontal fringes at the end of the day. So one of the main questions that needs to be answered at your point is, what are you modeling and at what scale you are modeling? Are you looking at a very refined scales, 5th, 6th order stratigraphy, or are you looking at 3rd order stratigraphy or 2nd order stratigraphy? And this is one of the main questions that I always usually ask people whenever they are looking at their plays. At what resolution are you looking to your plays, and how are you going to de-risk your play at some point? This is an example of two models, a model at 20,000 year time step, looking at Milankovitch cycles, where you can clearly see some channel systems developing of compensation stacks. Everything here in orange and yellow represent sandy components, and everything here in green represent more shaly components. And you can see we can track some stratigraphic trapping mechanisms. This is at the 20,000 year time step. Maybe at some point, this scale is still at subseismic scale. But you can see that whenever we're generating super high resolution models or ultra high resolution models, you can clearly see the amount of vertical resolution and lateral resolution you can get. And sometimes, as the previous speaker said, it's not only important to look at structures, it's very important to look at seismic and stratigraphic trapping mechanisms, which are usually at subseismic scale. So you will be needing to integrate well data, you will be needing to integrate seismic data and numerical forward model to generate an assessment of the subseismic features, architectures, or geometries. Something which I always look at and I always also promote is sensitivity analysis. This is an example of a sensitivity analysis of different models. You have facies, you have sand components, and you have water discharge. Here I'm showing you different models, one model with high sand content and one model with low sand content or high shale content. And you will be able to see the different geometries and patterns into your models and how are the sedimentary system being actually impacted by by the diversity and the composition of your system. And this, of course, will have a major impact on your petroleum system elements and the de-risking of your place. So you have to be very careful. And following my discussions a lot with ONGC and many indigenous collaborators, these tools are very important to de-risk as much as possible in areas where we don't have a lot of information. Going back to carbonate system, I'm showing you here a very nice work that has been conducted for the Kuwait Oil Company, and this is mainly conducted for carbonate systems. You can see the influence of sea level changes on carbonate platforms. You can see the geometries, the retrograding, the prograding geometries. Everything that you will see in light white or light blue represents very shallow marine environments, and everything you will see in black here or dark blue will represent deeper water systems. You can clearly see the small shoals in yellows that we were able to interpret and de-risk. And at some point, these are very important patterns that we need to focus on whenever we're de-risking carbonate systems. Another brief examples, and I want to show you also the de-risking of oolitic shoals, and I'm sure that there's a lot of work conducted on this on the Indian side. This is an example of a comparison between a forward stratigraphic model showing the evolution of a system from carbonate deep water into oolitic shoals in yellow, and then the evolution of big fluvio-deltaic systems that will come into the development of your basin. For those of you who are very aware of shoals, know very well that shoals develop in very shallow marine systems. They are of high energy deposits, and they are very linked to the lighting process. This is an example of a prediction of extensive shoals in the southern part of the country, but in the northern part, you can see that the shoals are more localized and more restricted. And this is a very important pattern that needs to be de-risked whenever you're looking at carbonate systems. The advantage of using forward stratigraphic models is that we are able to model the process, or the regressive process in this case, in time. So we will be able to reconstruct time and reconstruct facies and architectures in time. And this is what you want whenever you're looking at the holistic approach of de-risking plays and sequence stratigraphy. Now going into a bit more high resolution systems and at platforms, at prograding platforms, this is a work also conducted on carbonate systems of the Tethys region and the Arabian Plate, a work published for ATCO, so the Abu Dhabi company. You can clearly see what we were able to model. We were able to model different types of geometries: algal mound, coalescence and generation of platforms, prograding geobodies, and all of this will help us understand also the variability of facies in your lagoon. You can see that through forward modeling, you can de-risk mud ponds, you can de-risk shoaling events, the location of big belts, rudist belts or Corallian belts. So the main key point message that I want to transmit to you all, guys, is it is very important whenever we're looking at a process, or it's very important whenever we're looking at the reservoir, to be able to de-risk and to use sensitivity analysis for that. Because one single geological model, unfortunately, is not sufficient anymore. We need to use the power and the capacity that we have in calculations of our computers and super high processing speeds that we have into generating what we call sensitivity analysis on facies, sensitivity analysis on thickness of your different petroleum system elements, reservoir, seas, stratigraphic traps, but also later on integrating all of this data in basin models. This is another example showing you a mixed system where you have fluvio-deltaic system getting into a carbonate reservoir and the influence of fluvio-deltaic systems on carbonate systems. So now I'm shifting also, and I'm sure that Dr. Wygrala will be talking a lot about organic matter in his presentation, but this is just to tell you that we can also model organic matter using forward stratigraphic modeling techniques, and to be able to predict TOC and HI evolution through time, and then use this prediction in basin models that I will be showing you in the next slide. So just to finish the presentation, what we are looking for is generating, of course, a facies model, a structure and stratigraphy that we generate through our well data, to our seismic data. But what we will inject also into our basins model and later on into our reservoir is a facies distribution. This facies distribution is now based on processes. And then we can generate and link processes to the petrophysical behavior that we have, looking at source rock, injecting all of this depositional and geologic environment into a basin model, and then simulating numerically, and then calibrating the basin model through the well temperature data, well pressure data, hydrocarbon volumes, and finally generate accumulations and de-risking of accommodation. Finally, this whole integration or this holistic approach of using G&G data and numerical data will end up with an integrated play assessment and risk. I will not go into a lot of details in this. This will be maybe in a later presentation, but for those who are interested, you can follow up on published paper. We integrate all of that we have into CRS and CCRS maps for reservoir seal, trap, charge, and generating lead area maps. On these points, I will end up the presentation. I will thank you very much for your attendance, and hopefully we'll be having a lot of interesting discussions in the couple of hours to come.
Okay, thank you. Thank you very much for the talk. A lot of really key points. Scaling is something that you emphasized, and that really is critical as we move from basins to plays to prospects. So I'll start my talk right away. We're running a little bit late already, but we might have to shorten the Q&A session at the end. So we hope to finish the overall session on time. So I'll just see if I can. Good. Fine. Thanks very much.
No problem. Okay. So we're going live now. Okay.
Okay. Yeah. Okay. So I hope everybody can see the screen. I'm in full screen mode now. And let's just move ahead straight away. So we've seen probably in every talk, we have a similar introduction to the role of petroleum systems analysis, play analysis, etc. And what I'll be talking about here is how these things fit together a little bit more. We'll talk about very quickly at first petroleum systems analysis and then play risk analysis, and then we'll look at how this fits into assessment of undiscovered resources. You can see on the left a typical exploration pyramid. This is a popular one based on Milkov, and we can see all of these green objects here. These green fields are tasks that we need to undertake in exploration as we move from basins to plays to leads to prospects. And I'll just switch on the laser pointer and hope you can see it. So we'll first look at petroleum systems analysis, and this has already been introduced several times, so I hope everybody is aware of this. We have the basic factors: source, migration, seal, trap, and reservoir, and these in exploration are all uncertain, so they're risk factors. So a key point here is everything that we do has uncertainties, and in the end, for resource assessment, for example, we need a probabilistic approach to get the final results. For petroleum systems analysis, and this was already sketched briefly in the previous talk, we construct, if we have sufficient data, digital basin models. We can also work with purely conceptual models to gain additional understanding and test the concepts. The petroleum system we've seen is a combination of elements and processes, and so we use the digital basin model, and we model the processes through geologic time. This is critical. There are quite a few parameters that we simply cannot understand from the present properties. We need to look at this through time. So this is an offshore basin, in this case in Brazil. If we want to understand, for example, the gas-oil ratio in a prospect, we can only do that if we look at the processes through geologic time that create the hydrocarbons that migrate into this target. So even if this is a typical pre-drilling approach, we need to assess certain properties in plays and especially in prospects. Pressure, temperature, petroleum properties are typical. Once again, we have the petroleum systems risks, and we use these to define risk models. And the risk factors in risk models, these are used in the play risk analysis, and the risk factors are based on our understanding of the petroleum systems. Some of them can be mapped directly. So we use, for example, GDE maps to populate the petroleum systems models. But for others, and especially this is related to risks, charge risks, which are combined from source risk and migration, we can only assess these with process modeling, in this case with the forward modeling that we use in the petroleum systems models. So this is just the same. We run the models through time. We can test different scenarios, and we need this to understand the distribution we're interested, for example, in where are the potential generational kitchen areas, where are the potential accumulation areas, and this is mapped. These are risk maps that we can later on use for the play chance mapping. So you can imagine here, the overall geometry here is very similar, for example, to Kerala Konkan, and we need to understand potentially where could we be generating, and then we need to understand, well, potentially where could we be accumulating, and this is a function of the property distributions and obviously of how the processes operate through geologic time. So once again, if we have little data, we can also work with purely conceptual models. But for Kerala Konkan, for example, it is possible to assemble 3D petroleum systems models just like this. Play risk. Critical point here is to manage the definitions. So we know what the definition of a play is, and we also know what features are. This term features is very important in resource assessment because we use a feature-based approach to identify the undiscovered resources and the risks. And we have standard concepts that we need to adhere to. We have unproven play, so we can obviously, in green here we have the basin, pink we have the play extent, and we have an unproven play and we have a proven play. This differentiation between unproven and proven is also critical for the risk assessment, for the play risk assessment and the play risk mapping. So most of what you're seeing here are based on publications from NPD in Norway, the Norwegian Petroleum Directorate, who have an exemplary library of public data. For example, it includes a play catalog. So Dr. Bastia early on showed a nice summary play map and what we need to do. And this typically based in Norway, for example, on the National Play Catalog. And this is issued by the regulatory authority, the NPD. And so you can see these descriptions. And this is maintained and changed continuously. We have plays which are not yet proven. We prove them through time. So the overall resources and the undiscovered resources change continuously. And they're updated, for example, in Norway, on average every 2 years. Once again, we look at the petroleum systems. We have a standard risk model. We construct play risk maps, and we can use simple colored maps to combine the different maps and look at overall composite risk maps. These are all standard processes, but we need to be very careful with these maps. You cannot separate them from the underlying data. So when you're looking at play risks and prospect risks later on, you always need to go back to the underlying data. There are quite a few pitfalls. The method is good, simple, but we need to be careful. The result then is, with the composite risk maps, this could, for example, be a chance of success. Specifically for a specific target, we might be looking for a chance of success for oil or for gas, and so we can filter the data and come up with these maps. So all standard processes. So now let's look at the main goal and what we're trying to deliver. This is the goal of this talk. The assessment of undiscovered hydrocarbon resources, and they're also called yet to find YTF resources. So PRMS was mentioned earlier. This is a standard approach in the E&P industry to define resources and reserves. And they clearly differentiate between discovered resources and undiscovered resources. And there is a critical difference here in that for discovered resources, there are clear guidelines and the certifications, and these are well defined and the industry can follow these directly. For undiscovered resources, there are no guidelines. And what we do is follow industry best practices. So this is critical. And who defines the industry best practices? What can we use? This was a topic that we discussed before we did the national assessment in 2017. And there are some very clear choices for industry standard best practices. The key references that are most widely used, and these are also what was selected for the 2017 National Assessment, Norwegian Petroleum Directorate, because they're clear, they're clearly defined, and they publish everything. So this is clearly one of the best references. Also, the US Geological Survey, or Petroleum Assessment, for example, and a standard reference for play-based exploration, publications by Shell, and for exploration risk models, publications by ExxonMobil. The key requirements for resource assessments, it is play-based, and this is the topic of the meeting today. We're talking about play analysis, play-based exploration, and they are probabilistic. Also, if you look at the definitions, for example, from the USGS, they are geology-based. This should be obvious, but it's quite critical. You can't just base assessments on a few maps. You really need to understand the geology, and they depend fully on our understanding of the plays in the petroleum system. So it's always this combination. A couple of definitions are critical, industry standard definitions. We can differentiate the resources that we have between in-place and recoverable resources. So this is what the molecules that are basically in the reservoirs, in the rocks. But we're only interested in recoverable resources because they only have commercial value. And so a resource assessment is directed at recoverables. So we need to look at recovery factors for that. That is done. That's not a problem. Then we need to risk them. So we're looking at the uncertainties. We have success cases when we do risking. We want to know what could we find if we are successful, but there are risks. Not every well is obviously going to be a success if we're looking at a basin. So we need to risk the entire basin following standard procedures, and what we report are the risk cases, and we aggregate the risk cases, and this gives us the final results. So industry standard best practices, once again, NPD, Norwegian Petroleum Directorate, also excellent material from BOEM. This is the offshore agency in the US that defines standard terminology and definitions. So YTF are reported as risked, mean, recoverable resources. So it's very clear if you're comparing numbers to be sure what the definitions and what numbers you're looking at. We then, for the assessment, we subdivide the basin into plays. So we have a play catalog. These are typically based on stratigraphy. Then there's an important step because we don't analyze the risk and the undiscovered resources in an entire play. That would be a bit too simple. We subdivide the play into so-called assessment units. And the assessment units are defined as reflecting variations in geologic characteristics and risks. So we typically might have maybe 6-8 assessment units in each play that we're assessing. Once again, we assign industry standard risk models, and they are connected to our understanding of the petroleum system. So all of the speakers so far, you've seen this again, everything is dependent on our understanding of the geology, and this is the understanding of the petroleum systems. The risk model is very important too. We need a standard. So once again, a risk model is a collection of risk factors which are based on the petroleum system. So you might have a risk model that has, let's say, 5 or 6 risk factors. And then there are several risk models. Typically, there's one here we're looking at from Shell, and there's one here we're looking at from ExxonMobil. And what we do when we define the chance of success, we look at each assessment unit, and we look at each risk factor, and then we assign a value. This looks a little bit simple, but we assign a value between 0 and good because we want to use multipliers to create the maps. So this is a simple looking process, but it's very effective, but there are some requirements. I'll show this in a moment. You can see in both of these the term confidence, knowledge, confidence here in the ExxonMobil model. This is critical. Where does the confidence come from? If we just assign numbers, we're just gambling. If we have no knowledge and no understanding, we might just assign a 50% risk or 0.5 for everything, and we're just rolling the dice. So confidence is critical. Quality insurance is what we do to ensure confidence so that we have a consistent analysis of the potential. So all the terms must be clearly defined. We have guidelines. We develop guidelines for this. And so for the National Assessment Project, we have very clear guidelines that include definitions. All of these values are given by the assessment team. They are geology-based. So nobody just guesses at what the risk values and the risk numbers are. They come from the geoscience experts. The values are controlled by the confidence. What is the confidence based on? It's based on the knowledge of the assessment team. So this obviously depends on the data, on analog studies, which are critical. We have many basins in India where we have very little subsurface data. We need to look at analogs, global analogs, and they are based on analysis and modeling, the petroleum systems modeling, and other approaches that we've seen in the previous talk. All of these values must be justified. We can't just put a number in a table. We need an explanation. So people who are working with this database must be able to go and check and see why were the values assigned. Then an important term here is parity. We need to ensure that we're working from a common base, a common understanding, and if we're looking at a project like in India, we have a quality assurance team. This is a team of national experts who know many of the basins. They need to ensure parity in the process. This is the standard approach, and this works quite well. There is a lot to do, so we're not going to talk about this slide because these are all things that could be done. We could talk for a week about this. You can see you need to establish a team, you need to define standards, you need to store the data, you need to do the petroleum systems analysis, play risk analysis, then you need additional support data for the assessment, and then you need to manage the results. So these are all topics that we can talk about, but I don't think we have enough time right now. But the presentation here, all this material is public, so you can obviously have copies. So the results, these are examples from the US offshore from the agency, from the Norwegian continental shelf. I've been using these as templates. Also for the 2017 project, we looked at these again and again to see how people are reporting the results. You can see here, this is for Norway. We have a total number of plays, 69 plays in the country, and confirmed plays, 37, unconfirmed plays, 32. So this is their play catalog. And then you can see this is an example. They can aggregate the results from the different plays into specific areas. So here, for example, they might be looking at the Barents Sea, Northern Barents Sea margin, etc., and the Southern North Sea. Obviously, the green is for liquids, and the red is for gas. We can immediately see in this overview, if we're exploring for gas, we have the highest potential, but also the highest risks. These are the distribution. So we can see the difference between P10 and P90 because we've done a probabilistic assessment. Here we can see we're in an area where we've been producing for a long time, and we have very high certainties here because we have a lot of data. This is what we want to see from the regulatory authority. This is just an example of how to present the data. So, just a few comments from for the national project, and I obviously cannot show any numbers or specific basins. And but the two slides I can show here were presented. I was invited to give a keynote talk at the SPG meeting in India in 2017 after the end of the assessment. So these slides are public. We'll just have a quick look. The work was done by the ONGC asset teams. They did a fantastic job. It was really a huge project, quite unique. Every basin in India was assessed. The project was assigned by DEH to ONGC, all work undertaken by the asset team members, and I think this is easily the best solution because these are the experts and the results depend on the geological knowledge in the area. I don't think, for example, this would have been very meaningful to assign it to, for example, to outside consulting companies. This was definitely the best solution to have this work done. Then you can see here, we have 26 basins. They were subdivided into 180 plays. The plays were subdivided into more than 800 assessment units. So remember, in Norway, we're operating with about 70 or 80 plays. Here in India for the project, we defined 180 plays. All of this work done by the asset teams following a standard process, 800 assessment units. The risking then done for each of these assessment units following a standard approach and a standard risk model. And we end up with 50,000 input data entries into the first database. And this enabled us to do a probabilistic assessment of the resources, the undiscovered resources. Once again, I can't show any numbers or basin names, but this is just a cartoon basically to show how valuable this database is. It's a fully integrated database. It's not a bunch of Excel tables or something. This is really managed. It's a secure database, and management can just say, well, I want to see the best basins. So here I can see the best basins. Then I might want to look into a specific basin. What are the best plays? And I want them to be ranked by recoverable undiscovered resources. I can then go into a play and say, well, I want to see what are the best assessment units. So all of this information is in this database. And you can easily generate, DGH now owns the database, and you can easily generate the sort of maps that I showed from the NPD, from the US offshore agency. All of the data is included in here, following the same industry standard practices. So the value of this study for DGH is the first point, that for every basin, the asset teams wrote a report, and there are probably, I just guesstimated this, 10,000 pages of the G&G basin reports. This is really a treasure for the geoscience studies in the country. It's never been done, so this is a fantastic standard reference. Then, as I mentioned here, we have a database with play-based probabilistic assessment of the YTF potential in every basin, play, and assessment unit. We followed industry standard best practices, and this enables us, because the play risk has been defined in each of these assessment units, to support an objective ranking of the exploration potential. And then we used integrated deterministic and probabilistic. So the deterministic assessment is done with the petroleum systems modeling, probabilistic with the play evaluation, and this is also a foundation for future prospect and value assessments. So what you've seen on the map from Norway, for example, this was all set up for DGH in this assessment. So I'd like to thank the Director General of Hydrocarbons again for inviting me to present this. It was a really fantastic job on the project. A lot of stories to tell, but I'm running out of time here. And key references here that I always recommend, Norwegian Petroleum Directorate. For example, you can get there is a complete archive of the resource reports, so you can see how this develops through time. And Shell Play-Based Exploration Guide, a very useful little document. And also, please feel free to contact me and by email here. So thanks again to the organizers for the invitation. Okay, right. So that ends the session. And I would like to thank the speakers. And we'll just see. Okay, so we're getting just very quickly a little bit over the limit already, but I'm just getting a few questions here. Let's just see. I'm not too sure about the first one. There's a question here. Maybe if you could send me an email. This is from Palachi Jami. If you could send your question to my email address, we could discuss this. Then there is a question from Amit Singh. The database is huge, and specific part of this database should be shared with operating companies. Certainly, I agree with this, and DGH agree with this. So it's DGH is obviously following policies on publishing this. It is their data; they own it, and so they know exactly how to use it. And then there's a question, this is a good question, how often should the database be updated? The database update is a continuous process. So if you look at the industry best practices, the agencies that I mentioned, US and Norway, for example, they have a team that updates the database continuously. The next question is then, how often are the updates published? So typically you might be looking at a cycle of every 2 years where a public update of the database is published, but updating itself is a continuous process. Every time you have new drilling information that affects the play risk, you might be even opening new plays, or you might be downgrading known plays. This is a continuous process. And as you saw here, 26 basins, 180 plays, 800 assessment units. If they're managed in a database, in a secure database, you change one value, the process of updating the entire database is automated. So it's not a problem to do these updates. Okay, thanks very much. So a little bit over the time, apologies for that. But then I'll hand it back to the host. Thank you very much.
I'd like to thank all the eminent speakers for that knowledge-bearing session. Thank